Hi, in this video we will learn how to compute determinant using row reduction. Well, so far remember that we have only one way to compute the determinant of a matrix, which is, well, cofactor expansion. Now this will provide another way of computing determinant. And well, what is the trick? Trick here is based on two things. First of all, that we can transform any matrix to an upper triangular matrix. Well, an example of that is reduced row echelon form, but reduced row echelon form needs a lot of work. You don't need to go that far. Any upper triangular, you can go transform matrix to any upper triangular using elementary row operations. And when you get to the upper triangular matrix, you know that determinant, this is the second trick, the determinant of an upper triangular matrix is equal to product of the entries on the main diagonal. So, well, if you want to compute the determinant, keep track of changes at each stage of this row reduction. And then when you get to upper triangular matrix, you know how to find the determinant. Just multiply entries on the main diagonal. And together, one factor comes from here, another factor comes from here. Together, you will get the determinant of the given matrix. Okay? So you can go to upper triangular using elementary row operations, and you know how to keep track of the changes of the determinant. Let's see this in some examples here. Okay, here, well, I have the first one. You see, to change this to an upper triangular, it's enough for me to interchange these two rows. I'll write the elementary row operations up here, so I will change R2, R3, but keep track of determinant on the main line. Okay, so if you interchange the row 2 and row 3, you will get this matrix. The first row, however, stays the same. So this is the row operation, but we know that how does that change the determinant? You have to multiply the determinant by negative sign. Very nice. This is now an upper triangular matrix, and we know how to compute the determinant of an upper triangular matrix. Just multiply entries on the main diagonal, and that will give you the determinant of the original matrix. Well, this is the part for the upper triangular. This is the part from the changes introduced by the elementary row operations. Okay. Let's do the second one. The second one probably needs more space here. Let me just do it. Okay. So as I said, I will start doing the operations up there, but the changes of determinant on the main line here. Okay. So I like to start this thing by interchanging row 1 and row 3. Okay, why? I like to have 1 up there. So this will be 1, 4, 3. And down there it will be 2, 1, negative 2, negative 1, 1, 2. And while we know that determinant, how determinant changes if you interchange 2 rows, you have to multiply determinant by a negative sign. Very nice. The second step is that, okay, now we want to get rid of this one, this one. What kind of operations we need? Well, for the first one, we need to add row 1 to row 2. For the second one, we need to do row 3 minus 2 row 1. So this way we get 0 here, 5 here, 5 here. And this will be 2 minus 2 times 1 is 0. 2 minus 2 times 8. 2 times 4 is negative 8. Plus 1 is negative 7. Negative 2 minus 2 times 3, this is negative 8. And this will give us 1, 4, 3. The first row, we don't change it. Very nice. But these operations, these elementary operations doesn't change determinant. So determinant stays the same, but don't forget to carry over the negative sign from the previous step. Very nice. Now we want to get rid of this guy. How can we do that one? Okay, so I can multiply row 2 by 7 over 5. I'm dividing by 5 to make this one 1, and then adding to 7 times of that, adding to negative 7, it will make that one 0. So this is row 3 plus 7 over 5 row 2. Okay. So this will make what? This will make 0, 0 here. 7 over 5 times 5 is 7. Added to negative 8 will give us negative 1. Everything else stays the same. Well, you could have to do this one in different ways, but I like to do this one here the way I wrote down. And we know that this operation doesn't change determinant. So determinant stays the same. However, we have a negative sign from before, and we have to carry over that one. Now, this is done. This is an upper triangular matrix, and determinant of that is product of the entries on the main diagonal, which altogether gives us 5. Very nice. How about this one here? Okay, so this one needs a little bit of work, but if you look a little bit closely, you will see that, okay, I need to interchange row 1 and row 3. This guy is better to be in the first row. This will make 1, negative 1, 2, 5. And here's 0, 0, negative 2, 2, 0, 0, 0, 3, and 0, 2, 4, 1. This operation, you have to multiply the determinant by a negative sign. Very nice. Now, I want to bring this guy up here. So we need to do interchange row 2 by row 4. This way we have, this is as before. This way we will have 0, 2, 4, 1. And well, this will stay the same. And this guy here will be negative 2, 2. And we know that this operation will introduce a new negative 1 sign. And while we had another negative 1 from before, so we have to carry that over, and we have it here. almost there. If we interchange these two now, these two, by the way, you multiply, get plus sign there. Well, I mean, they cancel each other. And then now I want to interchange row 3 and row 4. This way, I will have 0, 0, negative 2, 2. Here will be 0, 0, 0, 3, and then 0, 2, 4, 1, 1, negative 1, 2, 5. And again, since we interchange two rows, the determinant will be multiplied by negative sign. From before, we have nothing to carry over. Before, there were two negative signs, they cancel each other. We are done almost. This is an upper triangular matrix, and we know what is the determinant of upper triangular matrix. Just product of the entries on the main diagonal. So this is negative 12 times negative sign. This will give us a 12 here. Okay? And well, as you can see, it kind of offers a nice way to deal with the determinant. And well, better to learn this trick too for computing the determinant of a given matrix.